अस्सलाम वालेकुम। आज हमारा टॉपिक है टाइट्रेशन। लेकिन आज के इस टॉपिक में हम मेनली जो डिस्कस करेंगे वो है apparatus used in titration. Titration is a part of or a type of volumetric analysis. इस स्लाइड में आपको वॉल्यूमेट्रिक फ्लास्क नजर आ रही है और ब्यूरेट का कुछ पार्ट नजर आ रहा है। स्केचेस ऑफ ब्यूरेट पिपेट और ग्रेजुएटेड सिलेंडर नजर आ रहे हैं। लेकिन अब हम इसको इन डिटेल देखेंगे। पहले तो ये देखते हैं व्हाट इज टाइट्रेशन। टाइट्रेशन और वॉल्यूमेट्रिक टाइट्रीमेट्री is a common laboratory method in which the unknown concentration of a known solution is determined by allowing it to react with a standard solution using their volumes. And what are a standard solution? A standard solution means a solution of non-concentration. डेफिनेशन को समझने के लिए हम लाजमतन नेक्स्ट वीडियो भी देखेंगे और पहले apparatus को समझ लेते हैं। So apparatus used in titration or volumetry, this is iron strand, this is pipette filler. pipette इस स्लाइड पे कहीं पे भी मौजूद नहीं है, यहाँ है अलबत्ता। This is the pipette. So there are two types of pipette filler. One is this and the one of them is this. These are the aluminum flask or the conical flask. These are the volumetric flask. And this is the burette and these are the dropping bottle. So now see, there are two groups of the volumetric apparatus. Group 1, these are the non-volumetric glasswares. It includes test tube, funnels, desiccator, glass rod, and watch glasses. Test tube you have seen and you have used several times in your laboratory, and it is for heating or reacting a very small amount of a substance. In detection of ions and salt analysis, you will use these test tubes, and as well as in element detection. Funnels may be of glass or plastic. These are for transferring substances into a narrow mouth flask and for filtration as well. In titration, you will use it to fill the burette. All the burette can be filled without funnels, but it may spill out the content of the beaker. Desiccator has no use in our O-level, A-level, or intermediate or matric because desiccator are used for removing moisture from the substances. So ignore it for your syllabus. Glass rod, to mix the content in a beaker or any wide mouth container. Watch glass. Watch glass is a curved shape object, concave curved, and it is used to evaporate the liquid or to hold solids while being wet. इसको हम देखेंगे when in a video where we will show the preparation of a standard solution. So for this video, for titration, it has no use. Now group 2 are the volumetric apparatus. Volumetric apparatus are those apparatus which have certain graduations that mark the volume, and volume can be measured. And there are two classes of volumetric apparatus. Class A volumetric apparatus are those which has accurate volume. where the accurate volume can be um, transferred and to contain the accurate volume. For example, volumetric flasks are used to prepare a solution, a standard solution, a solution of non-concentration, because it has high accuracy for determining the volume. It has only plus minus 0.1, standard deviation of plus minus 0.1. If the volume is written 250 ml, it means its volume can be of slightly it may have slight deviation. Either it could be 250.1 or 249.9. So it is highly accurate. Pipettes. Pipettes are used in transferring the liquid between the container, and it is used in titration for transferring the content that should be taken into the conical flask. So from one flask to another flask, pipette is used. We have different types of pipette that we will see in the diagram later on. And it also has very high accuracy, that is plus minus 0.1. Burette. Burette. Burette is specifically for transferring an aliquots of solution for titration or some other purposes. It also has a standard deviation of 0.1, so it is also highly accurate. Graduated cylinder. Graduated cylinder can be of two types. Some are in class A. Those which are here in class A are a smaller one, and they have the standard deviation from 0.1 to 2, or maybe some others. So some of the graduated cylinders are in class A and some are in class B. So definitely if graduated cylinder has a standard deviation of plus minus 2, then it is the larger difference. Much it can affect the concentration or anything that is measured for a particular reaction. So those would be in class B. So actually in our syllabus, or the most common class A apparatus are volumetric flask, pipette, and burettes. And graduated cylinders can be of high accuracy sometimes, and but most of the graduated cylinders are of class B, which has a standard deviation of 2 or more. So as we have already seen in previous slide, that graduated cylinder can be of class B, but here beakers and conical flask are in category B because their standard deviation is minimum standard deviation is plus minus 2 centimeter cube to plus minus 5 centimeter cube, depending on the size of the beaker. And similarly for conical flask, it is also of plus minus 2 or plus minus 5. That is a very large difference. So we cannot use these for measurement. That's why some authors write beaker and conical flask as non-volumetric. Now see, this is iron strand. In this iron strand, this is called a rod or iron rod. This is the base, and this is called clamp for clamping the burette. So this whole apparatus is called clamp. So clamp is fitted on the rod, and rod is fixed to the base so that it can stand. Burette. Burette has either a top or pinch cock, and there is a very fine graduation. It is very accurate, and usually the burette that we use in Cambridge or intermediate level, it is of 50 ml, but burette can be of 100 ml or more. So the most common burettes are of 50 ml. In most of the burette, the volume written over here is the maximum volume. For example, here it is written 100, and at the top it is 0, because it is easier to calculate the volume consumed or volume allocated or dispenses from the tap. And during titration, this hole must be filled with the required or the desired liquid. Either it is a base, oxidizing agent, or an acid, whatever is in the burette. The least count, what is the least count? The minimum reading that can be taken. So the least count of the burette is 0.1 ml, or you can write it 0.1 centimeter cube. See, this is a short video for demonstrating that how purities look like. See, this is very important that when you start your titration, and although it is not necessary, but in our intermediate system, we always start with 0. And see, there are two meniscus, upper meniscus, and the lower meniscus. So we always fill it by observing the lower meniscus. And see, now you can see here, this is 50. So when we use the 50 ml burette, the last point is the 50. So from 0 to 50 is here. So after that point, if you will add any volume, that would be not measurable. Okay. And another thing in the burette, if you see, this is 49 and this is 50. So how many divisions are there? 1, 2, 3, 4, 5. So that would be 0.5. So the minimum reading that you can observe here is 0.1, that I have told you that the least count of burette is 0.1. See, another important thing, that although it is readable, but the thing that is not clear because of these bubbles. So we should avoid the bubbles at the surface or anywhere in the burette. And here you can read it very carefully. So think about it. What should be the reading? Okay, see, it is 30, it is 31, it is 32. So the least value is 0.1. So it is 0.1, 31.1, and this is 31.2. So 31.2 is this reading. Although we can read it as well, this is 10, 10.1, 10.2, 10.3. So this reading is 10.3. So no problem, although we can read it, but it should not be there. Bubble should not be there because it may cause a slight difference in your readings. Now, the next important apparatus is pipette. Pipette are of two kinds. One is like this, which is graduated. This is called volumetric pipette, and this is called the transfer pipette. Although both of these can be used for transferring the liquid, but what is the difference? Difference is that this pipette cannot measure the other volume except the volume that is written here. And its accuracy is 0.03. And the accuracy of this pipette could be of 0.01 or 0.01 is the accuracy for most of the pipettes. So it can transfer only one volume, but from here, from this pipette, you can volume any of these volume. If you are using pipette filler or just the simple using your finger, then you can stop it, stop at any volume when you are transferring, or uh, you can siphon it and siphon any volume through it. So siphoning means to move a liquid upward and to drain it again. So you can take any volume here and you can transfer. So this is more reliable and usable as compared to this. लेकिन इसका मतलब ये नहीं है कि you say that this is not good. These both of them are good. If you want to transfer a specific volume, then we don't need it. It's enough. Okay. And pipette can be of 10 milliliter, 25 milliliter. Even the micro pipettes are there, which can measure accurately 1 milliliter. See one of the graduated pipette here. It also has +1 and 10 ml is written here and 0.1 is written here. So it has the standard deviation of ±0.1. Now this is pipette filler. There are two types of pipette filler. One is this and one is this. This is the most commonly used, and this is very modern pipette filler. Both have the same function. I will discuss only this one because this is common here in our colleges and schools. So there are 3 points that should be pressed during the operation: A, S, and E. E means empty or eject. I should start with A. When you press the A and you squeeze this bulb, so air is released from here. So actually A is for air. Air is released from here. When you press it and squeeze the bulb, it will be empty. Then the second point is S. S means the siphoning. Siphoning means to suck the liquid. some people say S means suck. Yes, it is for sucking the liquid or siphoning the liquid. That liquid, when you press it and pipette is in the liquid, then it will help to suck the liquid. So you you can suck the desired volume of the solution or any liquid by pressing this. Then you have to draw the liquid. So for drawing the liquid, we press this E. E means empty the pipette, or eject. Eject means to release the liquid into another container. See this short video as well. This is A, this is S, and this is E. Now see its function here in this video. First, we press A. Now see, when we press A, it is squeezed. And now when we press S, it will suck the liquid. See, it is sucking the liquid. Now from E, we can drain it. Now it drains the liquid, eject the liquid. Okay. Again, when we use any glassware, we should observe the lower meniscus. Now see, these are the dropping bottles. There are different types of dropping bottles. Some are these. Just by tilting, you can transfer some drops of the indicator. And some are with this dropper. You can uh, suck this liquid in this dropper and dropwise add into the conical flask. These are the conical flasks. These are also called Erlenmeyer flask. And these are specialized for titration, but it also has some other uses in biological laboratories or in the laboratories for other functions. In titration, we use it because it has the narrow mouth. So the transfer of any content into the conical flask is not easier. And we can transfer our aliquot from the burette easily. So it is used and we can handle it very easily. Okay. So conical flasks are of different volume, either the 250 ml, 100 ml, or even the smaller one of 10 or 5 ml as well. But usually we use the conical flask of 250 ml in our laboratories for titration. And these are the volumetric flasks. We make the standard solution in this volumetric flask because they have high accuracy. Their standard deviation is plus minus 0.01 or 0.1. So these are used for making the standard solution. Sometimes we use these just for keeping the solution. And we can also use these flasks for making the dilutions, especially in biochemistry laboratories. We have to make different dilutions. In analytical chemistry as well, we used to make dilutions. So this is all about the apparatus or the glass spheres used during the titration. So in the next video, we will see how a titration experiment is performed.